Hey everyone, Dr. Walker here. In this video, I'm going to go over the guided example from video 213 on change in potential energy. This is a guided problem, so I really encourage you to pause the video as you watch so you can kind of do it on your own, but be guided by me when you need it. Let's take a look at the problem. It says, a charge of 1.2 microcoulombs is placed in a uniform 1400 newtons per coulomb electric field, pointing to the right. So there are two parts to this problem. The first part is draw a picture of the charge in the field. Which way does it move under the influence of the electric field only? So pause the video and draw the electric field pointing to the right. And I always like to draw the plates. It just helps me visualize that positive and negative plate that we had in the previous video or in the video associated with this lecture. So draw that, then draw the charge, and think about which way it moves. So, assuming you've done that, then you would have drawn a positive plate to the left and negative plate to the right, because if you do that, then you know that the electric field always points to the right. And I just like visualizing those plates. And now just put a positive charge in here and think about which way it's going to go. Alright, a positive charge will always experience a force in the same direction as the electric field. So it's going to experience a force to the right. So it's going to move to the right. So that's the answer to the first question, to the right. Okay, now let's forget about that. And let's look at the second part. If it moves 3.5 centimeters in the negative x direction, what is the change in potential energy of the charge? So first of all, we just said it would move to the right. But now it's saying, well, what if it's moving to the left? Well, if it moves to the left, that simply means that there is some external force besides the electric force that is pushing it to the left, and that's okay. So if it's moving 3.5 centimeters in the negative x direction, so I'll let you go ahead and write down the givens and then see if you can figure out the equation. If you remember the equation, write those down. Okay, so the givens are the displacement is in the x direction. It's negative 3.5 centimeters, which we're going to convert to meters, so negative 0.035 meters. What else is given? Well, we know the charge is 1.2 microcoulombs. Micro is 10 to the negative 6, so 1.2 times 10 to the negative 6 coulombs. And then we are given the electric field is 1400 newtons per coulomb. So it's positive is to the right. So did you write down the relevant equation? Relevant equation is the change in potential energy is negative Q E delta X. So before we plug in these numbers, maybe you already have, but if you haven't, think about it. Is your answer going to be positive or negative? Let's take a look. We have negative times 1.2 times 10 to negative 6 times 1400 times negative 0.035. So the two negatives will cancel out and our answer will be positive. And that makes sense. Because if the positive charge is moving to the left, then its potential energy is increasing because work has been done to push it to the left. When you plug in these actual values, you're going to get 5.8 times 10 to the negative 5 joules. So let me ask you a question just for you to think about. When the charge moves to the left, is the work done by the electric field, is it positive or negative? So think about it, and feel free to put your thoughts in the comments below. That's all for this problem. I hope that this was a helpful video.